this so I can put it up for people who are missing. All right. First question goes to, my mouse stopped on Brandon. Brandon, are you up for talking, or do you want to put it in the chat box? Are you there?
Yeah, I'm here.
Okay. All right, Brandon, your first question is, please tell me the state of matter where the particles are loosely packed together and they can like roll or float or slide over each other.
Liquid.
Liquid, very nice. Good job. All right, my next question goes to, my mouse stopped on Manuel. Are you there? Okay, thank you. Okay. All right, Manuel, here's your question. Please tell me the state of matter where the particles are super, super close together and they vibrate in place.
Solid.
Solid, very nice, good job. All right, next question. I gotta think of one. All right, I got one. And this is, where's my mouse? Oh, there it is. Skyla. Skyla, you there?
Yes.
Okay. Your question is, please tell me the phase change where you go from a solid to a liquid. Phase change where you go from a solid to a liquid.
Is it melting?
Yes, it is. Good job, melting. All right. Next question. Wrong mouse. Here we go. I've got two mice. I gotta think of a question. Okay, I got a question. My mouse is on Ryan. There, Ryan?
Yeah, I'm here.
Fantastic. Ryan, this is a silver cup. Silver cup. Is that a physical or chemical property?
That would be a physical property.
It is a physical property. Very nice. Okay. All right. You guys are too good at these. I gotta think of some harder ones. Let's see. All right, my mouse is on. Nope, Manuel already went. Skylar already went. Why is my mouse going to the same people? Tyson, you there?
Yes, I'm here.
Alrighty. Tyson, I would like the state of matter. The particles are very far apart and I can either expand them or compress them into a small space. State of matter.
Gas.
Gas, very nice. All right. Julie, there?
Yeah.
Okay. Julie, I would like, okay. Can you tell me, all right, you can give me any of these. If I add heat to a liquid and it turns into a gas, can you tell me the name of that phase change? So I add I add heat to a liquid and then it turns into a gas. What's the name of that phase change? So I'm going from a liquid to a gas.
Evaporation.
Evaporation, very nice. All right. I would like the other two names for those. I would like for Serenity to give me one, and the other person is going to give, that's going to give it me the other name is not myself. I know what the answer is already. Z. So Serenity and Z. So Julie said evaporation. There's two other words we could use. Z, what you got?
Boiling point.
Boiling, very nice. And then Serenity, are you there?
Melting point.
Not melting. So we want, there's evaporation, boiling, and then there's one other name, and it sounds like evaporation. Do you remember that one? Sounds like evaporation.
Is it vaporization?
Vaporization. Very nice. Good job. All right. Let's see. My next person is Daniela. Are you there?
Yes.
Okay. Daniela, you are riding down the street. Okay. You're riding down the street and you notice this yard and there's a bunch of old cars there. And all the cars are all rusty. So they're all apart and kind of rusty. Is the ability to rust a physical or a chemical property? Physical or chemical property? Rusting. Is that a physical or chemical?
Chemical?
It is chemical. Very nice. Good job. All right, let's do like let's do about two more. Let's see. I know which one I'm saving. Okay. Gotta get one. My mouse keeps landing on you, Skylar. You already went. Let's see who we got. Keeps landing on Skylar and Manuel. Okay. All right, Camille, are you there?
Yes.
Okay. I would like to know the phase change where you go from a solid directly to a gas. Solid directly to a gas. What's the name of that one?
Sublimation.
Sublimation. Very nice. I got two more questions. Josh. Okay. Josh, if you wake up in the morning and the grass is wet, so there's dew on the grass, what is that an example of? What phase change?
Condensation.
Condensation. Excellent. All right. And then I had two more. What was one of them? All right. This last question, whoever gets this, if you get it right or wrong, if you get it right, I'm going to be very impressed. If you get it wrong, I still won't judge you because this was one of the most missed questions. So this is why I'm asking it. So if you happen to get it, don't feel bad if you get it right or wrong. And Daniela already went, so who is it going to be? It's Jermaine. All right, Jermaine, you ready?
Yeah.
Okay. Jermaine, dissolving, is that a physical or a chemical change?
Physical.
Very nice. It is physical. Good job. Fantastic. All right. So that is a quick review. So now we're going to talk about chemical changes. So we're going to do some notes on that. And then I'm going to show you guys a demo and then we'll be done for.
Ask a question.
So Mariah, you're unmuted in case you don't know.
I'm not on mute.
Were you asking me something?
Yeah, I was saying, can I ask you a question?
Yeah, absolutely. Go ahead.
How is dissolving physical?
Okay, so dissolving is physical because, so when we talk about chemical change today, which we're about to do, we're going to talk about when you have a chemical change, you're going to make new stuff. So for instance, if I take this paper towel and I set it on fire, I'm going to make new stuff. You're going to see fire, you're going to get ashes, you're going to get smoke. And then if you guys remember the other day, Ryan said a lot of times when we do chemical changes, they're not reversible. So I can't pull that smoke and the ashes back out of the air and make this paper towel again. Now, usually when you think about dissolving, it's like if I put sugar in water and I stir it, I can't get that sugar back. Oh, but you can, okay? Because if I let that water just sit there, eventually it will evaporate and then I can get the sugar back actually. So it will be difficult to do, but you can do it. So chemical changes are not reversible, physical are. And again, with chemical changes, you're gonna make new stuff. Physical changes, it's the same stuff, it just may look different. Like for instance, if I leave my chocolate bar in the car, it's gonna melt, but it's still chocolate. Now I may have to lick it off the wrapper, but it's still chocolate. Thank goodness, because we don't want to waste chocolate. So, all right. So let's do some notes. All right. So I'm going to pull my screen up so we can do some notes. And then I'm going to turn it off in a second. I'm going to show you. Oh, wait. Yeah. And I'll show you a demo. Okay. All right. Here we go. So I'm glad Mariah asked that because, again, that leads right into what we are doing today. We're talking about chemical changes. Chemical changes. Okay. All right. And when I give you guys these, definitions, I try not to put it in super sciencey terms because I just want you to understand what's happening. Because then if I use all these science words and you're like, oh, this just sounds like this is happening, you still understand it. So I may give you some sciencey words. I try to explain it both ways, but realistically, for instance, chemical changes, you're making new stuff. Now, here's one of the things I want to emphasize, okay? Because earlier we talked about chemical and physical properties. When we talk about chemical and physical changes, you have to do something. You got to do something to it for it to change, okay? So that's the biggest difference between a change and a property. All right, so chemical changes, okay, those occur when a substance changes into a new substance or substances into a new substance or substances, okay? So substances change into a new substance or substances. So that also means a lot of times that you might have, you may have new properties, and those properties could be physical or chemical, okay? So you get new properties, we'll say get new properties, okay? Get new properties, all right? And then remember the other day, Ryan was saying, usually, okay, we always make exceptions in science, but usually, I don't want to say always, although it is almost always, usually the change is irreversible. Okay, so that means if I do it, I can't get the old stuff I had back. Okay, so once I make the chemical change, okay, I can't get the old stuff back. And so we haven't talked about like the atom yet and like proton. We know what a lot of people were saying, they knew what protons, neutrons, and electrons are, okay? But when we do a chemical change, basically you're just playing around with the electrons. Those move around, but the nucleus or like the heart of the atom doesn't change, okay? So I'm just putting that out there for those who know what electrons are. Okay, if you don't worry about it. We're not getting to that yet. All right, so now what I want to talk about is how do you know that you know that you know that you know that you had a chemical change? Well, I'm going to give you some evidence of a chemical change. Okay. So I have this like shortcut sentence that I'm going to tell you about. And it works. Okay. It works. But I am going to offer it to you guys because I offered it to my other classes. If somebody can come up with a better sentence, like a shortcut sentence, I had one person offer me one yesterday. I may be willing to give some points here or there. I don't know. We'll see. So the sentence is just to kind of help us remember the different things that we could look if there's a change, okay? So for example, don't write this down yet, but remember how you used to do stuff like, oh, my name is Peyton, and P stands for this, and A stands for that, and Y stands for that. That's what we're about to do right now. but I'm gonna write it the other way, okay? So this is kind of what we're about to do. All right, so here's the sentence. It's kind of weird, I'm not gonna lie to you. That's why I'm up for a new sentence. So the sentence is, oops, I need to actually be writing. Old grandma's country pies taste lovely. All right, I'll give you a second to get that written down. All right, so what we're gonna do is each one of these letters is gonna stand for a different type of change, okay? So O, G, C, P, T, and L are gonna stand for different change. Now, I'm gonna help you figure out what some of these are by telling you some chemical changes, okay? So you can just kind of unmute and pop in and tell me what you think, okay? And then that way we can make sure we have time for the demo. So let's pretend that I'm going camping, okay? And I decide that when I go camping, I need to build a campfire or fire, right? Why, if I go camping, tell me a reason why I would want or need to build a campfire, anybody? And you can unmute and tell me.
I'm going to be cold.
I do not want to be cold. That is true. So when I burn that wood, there is evidence. Burning wood is a chemical change, okay? So here's one of the things that tells me it's a chemical change. There is a change in temperature. E-R-A-T-U-R-E. If you see a change in temperature, you probably had a chemical change. For example, okay? I know, well, really a lot of people use, not just athletes, but when it's very cold outside, I usually keep hand warmers. Why, when I open that magical pouch, does it all of a sudden heat up? Or when I open a pouch and use it like the muscle relaxer pads, put it on my back, why does it heat up? It's a chemical change, okay? Or even the ice packs, right? Some of those you can crack them and then they cool off. Those are chemical changes because there is a change in temperature, okay? Change in temperature. So that's one sign that a chemical change has occurred. All right, why else would I need a campfire?
You'll probably like cook some food.
Yep, cook some food. So that's going to be under change of temperature again, okay? And what about going with that? What if I'm camping overnight? Why would I need a campfire too? So one, to stay warm, and what else?
Light.
Yeah, light, absolutely. So if you happen to see light appear, okay, if it's all of a sudden light is produced, like a glow stick, also evidence of a chemical change. All right. Let me see. All right, let's say I've camped, I stayed overnight, I did my campfire, I've packed up, I've left. You come along later on, you see where it was. How do you know that if the wood, everything's still there, but there's no fire? How did you know I had set that wood on fire at some point?
It was burned.
It was burned, and if it's burned, how does it look differently?
Ashes.
Yep.
It's black and there's little.
Very nice. Very nice. You got a different color, right? Wood that has been burned is a totally different color, okay? So if you see a color change, if something happens to be one color and all of a sudden you see it later and it's a different color, you had a color change, okay? That's also evidence of a fire. All right, one more. Let's say you're not close to a fire, you don't see it, how else could you know that something was burning?
The smell.
The smell of it, very nice. If something has an odor, that is also evidence of a chemical change. All right, very good. All right, so the last two, I can't really connect them with a campfire. One of them I kind of could, but I'll just tell you what these two are, okay? So one is if you produce a gas, okay? If you produce some type of gas, if you see a gas, then you probably had a chemical change. Now you may be asking me, Miss Payton, how can you see a gas? Most gases are colorless. That's true. However, you might see these. Okay. For example, okay. Now, hopefully, I don't throw anybody off, but for example, I went swimming on break. I happened to look across the pool and I saw bubbles coming out of the pool. They obviously thought that no one else could see the gas, but guess what? If there's bubbles, I know they let one rip. All right, so be careful if you go to the pool or if you're in the tub and stuff starts bubbling. They'll know what you did, just saying, okay? All right, the other one is called a, not precipitation, but a precipitate, P-R-E-C-I-P-I-T-A-T-E. A precipitate, okay? Now, precipitate sounds weird, and this is what the one I'm going to show you, because I know if I tell you, you're going to be like, that's crazy, you can't do that. But I'm telling you, you can. Okay, a precipitate is when I have two liquids, and if I mix them together, they can make a solid. That sounds really weird. Like, I just pour two liquids together, and all of a sudden, a solid comes about. That is possible, okay? Now, we may not see that one so much in everyday life, okay? We can see the evolution of light. We can see light appear and feel a temperature change. We can smell stuff, see a color change, see bubbles. But two liquids making a solid, I don't know about that. So let me show you what that looks like. I'm gonna leave this up. I'm gonna go pull my stuff over here. So if you're still writing, write that down. I'm just gonna pull my stuff over here to the table so I can show you how it works. Okay. La, 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 la. La, 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 la. Move my chair here. Safety first. I have my glasses. I'm putting on gloves. All right. Stop sharing for a second. All right, can you see me? Ow, I just ran into my desk. There we go. All right, I have two liquids here. Let me, I wonder if I can pull this down. Let's see. Oh, this way, maybe. Hold on, bear with me. Why is this? Oh, here we go. All right, I gotta look this thing. I feel like I got on a GoPro. It's weird. I should have got my little, all right. Aha. All right, I have two liquids. This one is called potassium iodide, okay? This one is called lead 2 nitrate. So I already poured the lead 2 nitrate in this test tube, right? So I'm gonna pour it. I promise you this is this. Sometimes people are like, no, I don't believe you. All right, so now I'm gonna pour a little bit of this into this test tube. Just a little bit. Get in there.
Put your goggles on.
I do have goggles on, I promise. Right there. Okay, right there.
You better.
They're safety. They are safe. I'm being safe. Safety first. All right. These are two liquids. Everybody can see these are two liquids, correct? They're liquids. There's nothing in the bottom. There's no solid. Okay. Prepare to be amazed. Abracadabra. Science. Okay. I'm going to pour some of this one into this one. Okay. Here we go. Is that okay? I'm just making sure. Let me move this. Go away. All right, here we go. Tell me what you notice. Abracadabra. It is yellow. And if you look closely, you can kind of see there's some stuff forming on the bottom. Now we have to do this like the cooking show. You know, on the cooking shows, they're always like, it just so happens I had one already cooked. Okay, so I'm gonna go grab the one that I cooked earlier. I'll show you what it looks like. What other evidence of a chemical change did you see? What's the first one you saw? Color change, yes. Here's what it looks like after it all settles. Can you see the powder at the bottom of it?
Yeah, I see it.
So that's what it looks like when it settles. So what happened was we have something called, it's a lot of it in this one. I don't know if you guys can see it. Let's see. Can you see? Oh, focus, Yolanda. Focus. There we go. You can see it's a lot of it in there. So you can see the liquid on top and then all the powder. That's a lot of powder. Good grief. All right, so what happened was, and we're going to learn about this later. Oh, yeah, you can see it good right there. Okay, is what we call a double displacement reaction. So they kind of switch. So you got some liquid, but you got a lot of powder too. Two liquids making a solid precipitation reaction. Okay, all right. So now let's go back to our notes. Let's see. Notes, share. Let's go. All right. So now those are evidences of a chemical change. We're almost done. What about if you go to the fair or you go to a carnival, or maybe it's Juneteenth or 4th of July. What do a lot of people do to celebrate? What's something you usually see around those times? Or New Year's Eve?
Fireworks.
Fireworks, very nice. Now, fireworks, what do you think out of all of these? What do you think you would see? Which one of these would be evidence of a chemical change for fireworks? Which of these? You think any of those are evidence that fireworks are chemical changes?
Odor.
Temperature,
and-
maybe.
For sure, absolutely. Odor, I have definitely smelled some funky fireworks before. I don't like the smell, it just smells burnt. What else?
Heat.
Heat, okay, yeah, so that goes with the temperature. So
Right.
The
temperature,
light, yeah.
yes, light, absolutely. It's dark outside and they light up the sky. And my personal favorite, anybody? One more, at least one more. So we said light,
Gas. The gases. The bubbles.
temperature, odor. There's definitely some gas, but come on, fireworks? What's the best part about fireworks? All the different colors, okay? So,
Oh, I thought, yeah, she said that.
oh, okay, I missed that. I'm sorry. So yes, the colors for sure. That's my favorite part. And actually, there's actually maybe I don't know how to put my camera back on you guys. I'm struggling. All right. And actually later on in the semester, I'll tell you how they actually make fireworks. It has to do with the different elements though, basically. All right, so this is evidence of a chemical change. So really quick, close out class. This is what we talked about. I'm hoping this next text, I think it's gonna be good. And this is what I'm thinking about, so don't hold me to this. I think I may pull just a few questions from our old test and put it on this new one whenever we test. We're not ready to test yet, I'm just saying. And then I think if you do better on your second test, I'll replace your first test grade, okay? So far what we have covered was physical, I'm gonna shortchange it. So physical and chemical properties and changes, okay? So remember, here's the big thing. We got to remember, for a change, you have to do something. You have to do something. So for example, to do something, okay? You have to do something. So for example, remember earlier I asked, I can't remember who I asked, I said, what color is this cup? Okay, well in that case, if I say the cup is silver or the balloon is red, That's a physical property. Now, if I say I cooked something, which is also a chemical change, and the pancake went from light brown to dark brown, that is a color change. That is a chemical change, okay? Chemical change, okay? All right, we also talked about phase changes. Are phase changes chemical changes or chemical changes? Did I just say the same thing twice? Are phase changes physical changes or chemical changes? Which one? Somebody tell me. Phase changes, physical or chemical?
I think they're physical.
They
but I
are
could-
physical. pH for physical, okay? So remember, chemical change, you make new stuff. With those phase changes, if I take water, okay? If I take water, states of matter, let me finish this. All right, phase changes. See, I obviously did not fix my back right. There we go. All right, phase changes are physical because I did not make new stuff. If I take a bottle of water, which is a liquid, and I put it in the freezer, it turns into a solid. It's still water. If I take it out and leave it out and let it evaporate, it turns into a gas. It's still water. It's just water in gas form. Or if I boil it and it turns into steam, it's still water. It's just gas form, okay? So phase changes are always physical. Any questions? Lots of powder. You can't see it. Can you see it? Maybe. This is the other one. All right, that's all I got. We'll probably have next week a quiz that's more focused on phase changes and chemical changes. Have a great weekend. Tulu.
Have a good weekend.
Bye. Have a good one.
Bye.
See ya.